Hello guys and welcome. Today we're gonna be solving the third problem from this year's Polish Mathematical Olympiad. So we are supposed to prove that if x multiplied by 4 to the x minus 2 to the y all over 4 to the x plus 2 to the y is equal to y multiplied by 4 to the y minus 2 to the x all over 4 to the y plus 2 to the x, then the absolute value of x has to be equal to the absolute value of y. Okay, so this proof is gonna have two parts. First of all, we would like to go on and prove the statement for x that is greater than 0 and y also being greater than 0. I'm not saying that they are greater than or equal to 0 because, well, if they are both equal to 0, then this will, well, definitely hold, and their absolute values will also be equal. So that doesn't really make any sense for us to consider this kind of a case. Okay, so for both x and y positive, what we're gonna get is, well, basically just the same thing as here. So I'm not gonna be rewriting the same thing once again. I'm not quite. I'm just too lazy for that. I'm gonna be honest here. Yeah, I'm just gonna only change the color. Okay, so this thing right there, and now we would like to go on and distribute those denominators we've got here on both hand sides, just, you know, cross multiplied, so that we have something to work with. Maybe something that will look a little bit better. So we have x multiplied by 4 to the power of x minus 2 to the power of y multiplied by the denominator from the right hand side, so 4 to the power of y plus 2 to the power of x, now the right hand side, y multiplied by 4 to the power of y minus 2 to the power of x, all multiplied by 4 to the power of x plus 2 to the power of y. Got me sore throat. Just kill me, guys, already. Okay, so now we can just go on and well, distribute those guys out. Yeah, so what we're gonna get is x multiplied by 4 to the power of x plus y, because 4 to the x times 4 to the y, and then negative 2 to the power of y multiplied by 4 to the power of y. That's going to be 2 to the power of y times 2 to the power of 2 times y. That's going to be negative 2 to the power of 3 y's, and then analogously 2 to the power of 3 x's, then negative 2 to the power x plus y right there, and on the right hand side something very similar actually. So it's going to be 4 to the power of x plus y once again, 4 to the power of x plus y, then negative, actually let's say positive, 2 to the power of double the y, the negative 2 to the power of, sorry, not double the y, it's triple the y, triple the x, and then negative 2 to the power of the sum of x and y. Okay, so, well, what do we see here? We've got the 4 to the x plus y minus 2 to the x plus y on both hand sides here and here. So maybe we could, you know, distribute y and x over there and maybe try to get all of it on the left hand side, for example, and try to, you know, like go and factor that stuff out. On the other hand, well, those two guys here and here are also equal to each other. The only difference is that, well, this guy is the negative of this guy. So there is no problem in, let's say, distributing x and y, let's say this way. So we're gonna have x multiplied by 4 to the x plus y minus 2 to the power of x plus y on the left hand side, also plus, not to forget it, x multiplied by 2 to the power of triple dx minus 2 to the power of triple dy, and on the right hand side what we're gonna get is y multiplied by 4 to the power of the sum of x plus y minus to the power of to the power of the sum of x and y, and then plus that y multiplied by 2 to the power of triple dy minus 2 to the power of triple dx. Okay, so we once again see that those two are equal to each other, and we once again see that those two are the negatives of each other. Yeah, so they have the same absolute value. So we just go on and, let's say, bring those two to the left hand side, because why not? And I really like them sitting on the right hand side. We can't really do anything with it. So let's bring them on our side. What we're gonna get is, well, let me actually go on and factor out those two guys right away, because I don't really want to rewrite all of that stuff once again. So 4 to the power x plus y minus to the power of x plus y is gonna be multiplied by x minus a y. However, now, well, those two guys are the negatives of each other, and so when we bring y multiplied by this guy to the left hand side, we now actually have to multiply it by the -1, and so we will be able to, well, factor out exactly that guy. And so what will I get, I mean, factor out also the negative sign. So what we are getting finally, I mean, eventually, is to the power of triple d x minus to the power of triple d y, everything multiplied by the sum of x plus y, and that's supposed to be equal to 0 because nothing is left on the right hand side anymore. Lovely. So now, well, we have to consider the cases, unfortunately, because this is the furthest we can get. This is the best we can get out of the original equality. Now, well, let's consider case 1. So for the case 1, or maybe case 1.1 actually, well, we know that x and y are not equal to each other. I mean, at least we assume they are not equal to each other, because if they were, then, well, our statement doesn't really make any sense to be proved. It doesn't really make any sense to prove a statement. So we assume that our x and y are not the same. So, well, if they are not the same, then either x is greater than y or y is greater than x. Yeah, that makes sense, because, well, real numbers are an order set. We are not dealing with any kind of irrationals here or imaginary numbers. So let's first of all consider the case where x is actually going to be greater than y. Okay, awesome. So if x is greater than y, then, well, this thing right there, or maybe I will actually go on and copy all of it for my proof to be a little bit more elegant. Okay, so we see that this guy over there is always going to be positive. That's always going to be positive. That's because, well, 4 to the x plus y is going to be always greater than 2 to the x plus y. Yeah, unless x plus y is, well, less than 1, then it's, well, not quite. However, now x is greater than y, so this thing is also greater than y, and to the triple d x minus 2 to the triple dy is also going to be positive, yeah, because x is greater than y, and here also, well, x is gonna be, I mean, both of those are positive, and we're just adding those, so definitely this is also greater than 0. And so we are just adding a bunch of stuff, a bunch of things that are greater than 0, and we expect it to be 0. That's, well, yeah, I don't really like it, honestly. So we know that definitely x is not greater than y. Lovely. So now for the case 1.2, we've got that maybe y is gonna be greater than 0. Sorry, y is gonna be greater than x. We know it's greater than 0. Okay, so let me paste the stuff from the above right here once again, and now what we get. Well, this thing right here is always going to be positive. Now, x minus the y is going to be negative, because, well, x is less than y, so that stuff right there is going to be negative. However, now, well, you see, 3 to the triple dx minus 2 to the triple dx minus 2 to the triple dy is also going to be negative, because, well, as you can see, to the triple dx is going to be less than to the triple dy, because y is greater than x. And this thing right here, well, we're just adding two numbers that are positive, and so it's also going to be, it's going to be greater than 0. So what it means, well, this thing as a whole is going to be actually, well, you guessed it, less than 0. What about this thing? Well, also it's going to be less than 0. And so what we are getting, well, we are actually trying to add up two numbers that are less than 0 and expect them to be 0. That doesn't really make any sense either. So what we get is that y cannot be greater than x. Well, if y cannot be greater than x and x cannot be greater than y, well, then they just have to be equal to each other, for God's sake. Yeah, so what we actually get here is that, well, x is actually equal to y, unfortunately. I mean, or maybe fortunate, because it was the same way we were supposed to prove. Okay, so if x is equal to y, well, then definitely the absolute value of x is equal to the absolute value of y. There is absolutely no problem in it, so we prove the statement. Okay, so that was the case for both x and y being positive numbers. The case for both of them being negative is just about the same, just, well, let's say that y is equal to negative a, well, then just say that y is equal to some capital B, which is equal to negative a, and well, work this thing out pretty much the same way. There is no problem in doing that. However, I would like to do something a little bit more interesting, because there is one more case we should cover here, which is the case 2 of, let's say, x being greater than 0, however y being less than 0. So one of those numbers is less than 0. Well, if x happens to be less than 0 and y happens to be greater than 0, there's no problem in just, well, swapping those, so calling x y and yx. Yeah, so those are analogous cases. So for one of those numbers being negative, what we're gonna get is, well, once again we do the pretty much exact same thing. However, this time I would like to make one small change. So when we've got this original equality of ours, so this thing, I would like to copy it, because I'm too lazy for writing it down once again. Yeah, and I would like it to paste it here. Now I would like to say that y, which is negative, is going to be equal to negative a for some a that's greater than 0. Well, that makes sense. I mean, definitely there will be an a such that y is equal to negative y, where a is greater than 0. That's actually going to be the absolute value of y. Okay, lovely. So we would like to now substitute this a here, saying that negative a is equal to y. Lovely. So that's what we're gonna do. Let's rewrite our statement once again. So that's gonna be x multiplied by 4 to the power of x minus 2 to the power y happens to be negative a, as we made it to be. 4 to the x plus 2 to the negative a is equal to y multiplied by 4 to the x minus 2 to the negative a. Oh, sorry. Negative 2 to the a, negative a is in the power of 4 minus 2 to the power of x all over 4 to the negative a plus 2 to the power of x. And then, well, we do the same thing that as we did earlier, so just go on and distribute, cross multiplying those denominators, where what we're gonna get is x multiplied by 4 to the x minus a, 4 to the x minus a plus, or minus, I'm trying to distribute those already, minus 2 to the power of triple the negative a, then plus 2 to the power of triple the x, and then minus 2 to the power of x minus a. Well, that's equal to, oh, sorry, not y. I should have put negative a here. That made me record this video once again. Negative a multiplied by 4 to the power of x minus negative a, then is gonna be positive 2 to the power of negative triple the a, then negative 2 to the power of triple the x, then negative 2 to the power of x minus the a. This is exactly what we're getting here. Lovely. So now, well, once again, we see that this guy right there is going to be the same as this guy right there, and once again, this guy right here is the negative of this guy right there. There's no problem in doing the same thing we did earlier, so just distributing the a and the x across all of those terms and getting those to the left hand side. So after doing that lovely stuff, what we're gonna get is, well, definitely here 4 to the power of x minus a minus 2 to the power of x minus a, I should draw an arrow here, yeah, something like this, multiplied by, well, x and now plus a, x plus a, because we are getting this negative a to the left hand side, we're gonna have to change the sign there. Lovely. Plus this 2 to the power of triple the x minus 2 to the power of negative triple the a. Okay, lovely. And that's gonna be multiplied by, well, x minus a, because we are getting it to the left hand side. That's also going to be equal to 0. Lovely. And now, well, once again, we have to check cases. So for the case 2.1, we have that, once again, x is going to be greater than a, because, well, if x was equal to a, well, then x would be equal to the absolute value of y, and then the absolute value of x would be equal to the absolute value of y. There will be nothing to prove for us. So x is greater than a. Now I'm going to check what happens if a is greater than x, but not for now. So x is greater than a. Let me go on and copy all of this beautiful stuff right there, over here, lovely. So for x greater than a, this thing right there is going to be definitely greater than 0. What about x plus a? Well, a is actually a positive number, so that's also going to be greater than 0. This thing right there is definitely going to be greater than 0, and absolutely nothing will change that. And now, well, also this thing is going to be greater than 0 because x is greater than a. So we're just adding a bunch of things that are greater than 0, and it will not work out to be equal to 0. There's no possibility of it, yeah? So what we get is that actually x is not greater than a. Now the possibility 2.2, which is a being greater than x. Let's try and cover that one up. So when a is greater than x, then what is happening here? Let's say then we are raising both 4 and 2 to negative powers. If we are doing so, well then 2 to the least negative power is gonna be definitely 2 to the negative power is gonna be greater than 4 to the negative power, because that's gonna be a 2 to the least negative power compared to the second to the negative power. So we have that this thing right there is gonna be negative. It's gonna be negative. Awesome. Here, well, that's definitely gonna be positive. What about this thing right there? Well, that's definitely gonna be also negative right there. And well, this thing right here. Wait, I screwed something up. This is less than that. X plus a is greater than 0. X minus a is less than 0. There should be negative triple the a here. Now it makes sense. Okay, so this stuff right there is gonna be greater than 0, and this stuff right here is gonna be less than 0. And so once again, we are adding two things that are negative and expect them to be 0. It ain't happening, guys. And so once again, if, well, neither x is greater than a or a is greater than x, they have to be equal to each other. So if x is equal to a, however, you see x was actually equal, a was actually equal to the absolute value of y. And so we see that x is equal to the absolute value of y. And this definitely implies that the absolute value of x is equal to the absolute value of y. And this is what we're supposed to prove. And we did it in, guess what? Both cases right there. And so we see that after all of this tedious problem solving and all of this tedious writing stuff out, we got the desired result, and we get that the absolute value of x is equal to the absolute value of y. I really hope you enjoyed this video, and see you in the next one.